Hey BC, this is day 1 of graphing parametric equations and eliminating the parameter. Directions: make a table of values and sketch the curve indicating the direction of your graph, then eliminate the parameter. So this is pretty awesome. You've never seen this before, but instead of x being dependent, instead of y being dependent on x equals something and y equals something, and you plug those numbers in, and then you get your x value and your y value. Isn't that fun? All right, so t is called the parameter, and I'm wasting time. All right, I'm back. So we have these t values that I thought were going to be given to us, but they're not. So you ready? We're going to plug in t. T kind of stands for time. So if we plug -2 into the x, into t for the x equation, what do we get? We get -4 minus 1 is -5. So let's do our x line. And then -1 plugged in, -3, 0 plugged in, and we see our slope of 2, right? Our y-intercept was -1, and we have a slope of 2. So 1 plus 2 is 3, and then plus 3 is 5. So now let's plug our parameter, the t, into the y, and we would get 1 minus -2, 1 minus -1, 1 minus 0, 1 minus 1, and what's our slope? It's -1, so we're decreasing here. All right, so now we're going to plot these points, and the coordinate points are x and y. So the x value is -5, and the y value is 3. X is -3, the y value is 2, -1, 1, 1, 0, 3, -1, 5, -2. This has a direction. Where did we start? We started here, and we went in this direction. So you actually have to have an arrow because it represents time. Now, isn't this just a straight line, right? They're not always going to be like that. We're actually going to have a lot of fun. To eliminate the parameter, we're going to solve one of them for t and then plug that in to y. And eliminating the parameter means write in just terms of x and y. So if we have x of t equals 2t minus 1, let's solve this for t. You know what I'm going to do? We don't really need x of t, we're just going to have x, okay? So we're going to add 1 and then divide by 2. And that equals t. We're going to take that and plug it into t of the other equation. You can go in any direction you want. All right, and let's see what we have here. 1 minus, let's call this 1/2 x, and then minus 1/2, and combine like terms. So 1 minus 1/2 is a positive 1/2. Okay, what do you notice about this and our line? Does this graph the line? A slope, or sorry, y-intercept of 1/2, and then the slope was -1/2. Isn't that interesting? Look at so it matches, but this exists for all x and y, whereas this only existed for the t's we plugged in. All right, let's do another example. We have lots of examples. I don't know if I'll be able to do all of them in the 15 minutes because I wasted a lot of time. Here are t values: 0, 1, 4, 9. I don't know who made this large box. I think it was me. But notice how I'm only picking numbers that you can take the square root of. So for x, what's the square root of 0? 0. Square root of 1, square root of 4, square root of 9. I don't know, let's do more. Why not? If it doesn't work, it won't work. But if it does, it'll be fun. Okay, and what's our y going to be? It's going to be whatever t is plus 1. 0 plus 1, 1 plus 1, 4 plus 1, 9 plus 1, 16 plus 1. Oh, that's why we didn't go this far, because those numbers won't fit. So now let's plot these points. So where do we start? We're starting at 0, 1. 0, 1 starts here. And then we have 1, 2. Okay, and you have to follow the direction. 2, 5. What does that look like? 3, 10. Uh-oh, not enough room. And is it just going to get bigger and bigger? Yep, so it started here and it goes up in this direction. So you need to make little arrows what direction you went. Okay, now let's eliminate the parameter. Are you wondering why are we doing this? It's just fun. It's a different way to graph. Your whole life you've been taught one way to graph, and what I'm showing you is that, guess what? There's a second way to graph. It's called parametric equations. Does this y equals x squared plus 1 match this? Yeah. Did you have any idea that it would be a parabola given that? Nope. So it's a parabola, but it's only defined for positive x values because x was equal to a square root. Let's keep going. These get really interesting. What t values do we get to use here? -2, -1, 0, 1, 2. I think these boxes weren't given to you and I typed them in for you. Isn't that nice of me? Okay, ready? We're plugging in the t, -2, into t squared minus 2. So that would be 4 minus 2, which is 2. And then 1 minus 2, -1. Oops, there go the lights. Sometimes you need to show work, and sometimes you don't. This is a day where I need to show my work. 9 minus 2 is 7. I'm going to double check that that's right. Just make sure that that's negative, and that looks good. Okay, let's do the y values. Now we're going to take our t value and divide by 2. So probably going to get some fractions here. -1/2. 0 divided by anything is 0. 1/2. 2 divided by 2 is 1. 3 divided by 2. I was saying divided by. That's my own word. I made it up. All right, you ready to graph? So we're graphing. So the t just tells you like your timing. And we're going to start with this x and this y. So x is 2 when y is -1. X is -1. Y is -1/2. Okay, put that there. X is -2. Y is 0. Make sure you know what direction we're going. When x is -1, okay, now we're at +1/2. What pattern are we making? Can you predict? What does this look like? We started here and we're going back up. Now, when x is, where did I leave off? Here. When x is 2, y is 1. And when x is 7, 7, y is 1.5. All right, so we started here. Yes. We went in this direction. So draw arrows. And then we like boomeranged around and went in this direction. Isn't that cool? It's a sideways parabola, right? Now, let's eliminate the parameter, and I'm gonna talk at you. So in calculus, we can only do, what am I supposed to do here? Solve for t. We can only do calculus on functions. X plus 2 equals t squared, and to get t by itself, we take the square root. If you look at this picture, is that a function? No, it is not a function. Then I take my y and I plug in the 2. Why is it not a function? It doesn't pass the vertical line test. There are 2 points for one x value. There are 2 y values for one x value. So we cannot do calculus on this thing. We cannot integrate this. What would be the area under the curve? It's a little confusing. And then but we can do calculus on these 2 examples, right? We can take the derivative, we can integrate, and so that's what we're going to do. And then we broke this into pieces by using parametric equations, and then we can do more calculus, because that is our goal in life. Our goal in life is to do more calculus. Are we ready for part D? Here we go. What t values should we? Oh, we have trig. Okay, so we want nice, pretty numbers that go well in trig. So let's do 0. We know, let's do pi over 2, and then pi, and then 3 pi over 2, and 2 pi. Okay, if you want to go again, you do 2 1/4 pi. No, 2 1/2 pi. Okay, so when we plug in 0 into x, we get 3 plus the cosine, 2 times the cosine of 0. And the cosine of 0 is 1. So 3 plus 2 is 5. What's the cosine at pi over 2? The cosine at pi over 2, remember this is 0, 1, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Those are the coordinate points we picked. Okay, so pi over 2, the cosine of that is 0. So we have 3 plus 0 equals 3. When you plug in pi, we'll get 3 minus 2, which is, oh my gosh, Katie, that's a 1. Okay, everyone, that's a 1. And then the cosine here is 0, so we'd have 3 plus 0, which is 3. And the cosine at 2 pi is the same as 0, so we have 3 plus 2 equals 5. Okay, oh, the y values. The y's are going to be sines. Cool. All right, we have negative 1 plus 3 times the sine at 0. What's the sine at 0? 0. So I have negative 1 plus 0, which is negative 1. When I plug in pi over 2, we're going to have the sine of pi over 2, which is 1. So we have negative 1 plus 3 equals 2. The sine of pi is 0, so we have negative 1. The sine of 3 pi over 2 is negative 1, so I'm going to have negative 1 minus 3. What's that? Oops. Negative 4. Need a little bit more room here. Keener. And then 2 pi should be the same as 0. Negative 1 plus 0, which is negative 1. Okay, neat. Now let's plot these x's and y's and see what picture we get. 5, negative 1, 3, 2, 1, negative 1, and remember our direction here. 3, negative 4, and then 5, negative 1. Oh, it repeats. Okay. Isn't that neat? What is it? An Easter egg? Is it a circle or an ellipse? Let's see, the radius is 3 and 2, so it's actually an ellipse. Awesome. Okay. I cannot believe that we finished this in the time that we did. And so after we finish this, then your homework are these 10 questions here. I have to fix this. Okay, messy, ugly, that's okay. Sine of t. Here we go. I have to solve for t. What the heck? To determine the parameters, solve for cosine t in x's equation. Okay, so let's, we solved for cosine. Okay. And now solve for sine over here. Oh, I remember what we're going to do. Okay, ready? This is going to be fun. Do you agree with Pythagorean identity that cosine squared plus sine squared equals 1? What do we have here? Do we have a cosine and a sine? So we're going to plug in cosine into this. What? And then the sine goes in here. And that's going to equal 1. And we actually get, this is the equation of an ellipse. Ta-da! So you're going to do this homework and you have to make your own table of values, and I think I left it blank. So use lined paper, or actually if you can use graph paper, that would be great. There are 10 of them, but we did 4 in 15 minutes, so I don't think it's that bad for class time and homework to complete this. To pick your t values, this one's chosen for you. Just look at the examples. So the square root, use the same one as we did before. and the sine and cosine use the same one as we did before in the examples.